All right, in this first half of this week's lecture lesson, we are going to talk about exceptions. I'm going to do a little demonstration of exceptions, how they're used, why they're used. It'll be a basic example and not one that is really geared towards real life, but it should demonstrate the principles that you are going to need to understand about exceptions, not just for the class here, but going forward, because exceptions are a modern or are part of modern software development. So exceptions are a way to transmit information about an error or an exceptional condition from one part of the program to another. And so everything about them is geared towards the program understanding what the error is and not necessarily the person or the programmer, although the programmer needs to understand it enough to be able to tell the program what to do about it. So we're going to start off by defining a chain of methods to be called. And so I'm just going to use a little bit of editing trickery here to create some boilerplate method code. Looks like we're going to have 5 different methods. We're going to say public static. Our method's just going to return a sample integer, int, name it method, etc. And we're going to actually pass in an integer too. So int input value. And then all we're going to do here is we're going to return the next method. So I'm going to say method, and I'm going to come back and rename each method so it has a unique name in just a second. So I'm going to return method whatever with the input value plus 1. So I'm going to pass it the input value plus 1. And then what we're going to do in our main is we're going to see what value comes back from all of these things. So this is method 1. And method 1 is going to call method 2. And method 2 is going to call method 3. And method 3 is going to call method 4. And method 4 is going to call method 5. But method 5 is going to be a little bit different. Let's get rid of that arrow above there. So method 5 is just going to return the input value plus 1. However, we're going to do a little trickery here and say if input value mod 2 is 0, that's our old is it an even number check, then we're going to throw an exception. And we're just going to throw a generic exception. I need to say new in front of it because I'm going to create a new exception. And I'm going to say, actually, let's do this before we show the exception. Let's show these methods working just for main, and then we'll see what will happen as we build up our exception example. So in this case, we're going to say int output value equals method 1, and we're going to give it a 0. And then we'll do a system.out.println output value is, we should do this as a format instead of a print line, %d, and we'll say output value. So this is an extremely simple program. We're dispensing with a lot of the formalities of commenting and things. And let's just see what happens as we walk through this program in the debugger. So let's debug our exception.main. We'll let it compile for a second. Okay, here we go. Oh, I put the breakpoint on the wrong line. So it's already run. Our output value is going to be 5. Okay, so, well, let's just finish the program here. And we see the output value was 5. Well, now let's set the breakpoint on the right line. Let's go back and do it again. Okay, here we go. So we're going to call method 1, and we're going to pass it a 0. So I'm going to step into method 1, and we see that method 1 is going to call method 2, but it's going to add 1 to the input value. So our input value coming into method 1 was 0 because that's what was passed. And we're just going to walk down our method call chain. So method 2 calls method 3, and method 3 calls method 4, and each method is incrementing the input value by 1. And then method 5 is going to get a 4 in, and it's going to return whatever it got in plus 1. So it's going to return the value 5. And you can see here on our call stack, we are 6 methods deep on our call stack, starting with main, and then main called 1, 1 called 2, 2 called 3, 3 called 4, 4 called 5. So that's pretty cool. So now we're just going to step out of our methods, and you can see that input value, or we're returning the value. And now we go back to main, and the value returned from everything was, of course, the value 5, which was ultimately returned by method 5. So that's kind of cool. Nothing really fantastic, but it demonstrates that we could call methods multiple levels deep on our call stack. Okay, so now let's add our little trickery here. We're going to say if input value mod 2 is 0, we're going to check and see if we get an even number here. Then we're going to throw a new exception. And I'm just going to use the generic exception, the base class of all exceptions. And we're going to say number is even. Now, here's one thing that a lot of mistake that people make. And there are different philosophies, but this is my philosophy. The string, the description that we give an exception, it's the message, is not intended for human consumption. It's not intended to be printed on the screen for your user to see. It's intended to show up in a log file, and it helps the programmers understand what happened after the exception was thrown or what might have led up to it. And so we shouldn't be using exceptions to drive what the user sees on the screen, or to deliver what the user sees on the screen. The program should handle the exception and come up with a sensible way to present it to the user. And method 5 has no idea who's calling it or why. So it really shouldn't do its own system.out.println unless we're just debugging. But methods, utility methods like this, should not be doing any output themselves because they don't know who's calling them and why they're being called. And so the best way to do this is to throw the exception, and the exception way better than doing an if check. Now, in this case, if you've read the announcement or the discussion board post that teaches all about exceptions, you'll understand that there are other ways that we could have handled the errors without exceptions. We could have an if check every step of the way, which gets really tedious and makes the code really hard to read. Or we can throw an exception and handle it by name, basically, because although we're throwing a exception that's the generic, we've already seen examples in our assignments as we've gotten errors over the semester where there's a number format exception or an input mismatch exception when we didn't get the right type. And that's just a special type of exception that tells us a little more precisely what type of error this is. So I'm using a very generic exception, and we'll get to a specific exception in a little bit. Now you'll notice that there's an error here, and the error is unhandled exception. So I either would need to catch the exception here, or I need to tell my method that it throws the exception. That way, whoever calls the method knows they might have to handle an exception coming out of this. This is called a checked exception. There are things called unchecked exceptions, which mean that we don't have to declare the throws. We still have to catch them before they bubble up. But if we don't, then they'll bubble all the way up, but the compiler does not force us to catch them. But checked exceptions, anything that inherits from exception, is a checked exception, and it's going to, it's not exactly true, but for our purposes today, we're going to make it true. They're checked, which means whoever calls the method that throws it has to be able to handle it or pass it along. So in our case, it's never good form to throw an exception to yourself in your method. And so when a method encounters an error condition, it should just bail out and say, I can't continue, and it does that by throwing an exception. When we throw this exception, nothing after this line of code will execute at all. The method is interrupted and it's done, and this extra line of input doesn't happen. So the method isn't actually going to return anything. Instead, we're going to follow this exception back up. Now to clear this error, I need to declare that my method throws a generic exception. And we'll see here now that method 4, who calls method 5, says, hey, I don't know how to handle this. Or I'm calling method 5. There's an exception that could come out of this. I'm not sure how to handle this. So I'm just going to pass it back as well. I'm going to say throws exception. And in fact, we're going to go all the way up the chain, all the way up, back up to method 1. So let's take care of that right now. And we're just going to say throws exception. All right, so that clears the errors, but now method 1 might get an exception. And so I'm going to clear this error, I'm going to try, and then I'm going to catch. And what kind of exception am I going to catch? I'm going to catch this generic exception. And then I have a block of code where I can say there is a problem. And so we'll do that. We'll say system.error.println, there was a problem in the code. Of course, your error message would be more specific to a programmer, and I'm not going to necessarily print this out for the user to see, but this is an example. And I mean, if this is a log message, then I could say this, and I would then say plus exception.get message. All right. There's one other thing that we could do that is helpful for logging, and that is every exception has a print stack trace method. So we could say exception.print stack trace. Now this automatically goes to the output, so it's not the best thing to do, but in our main method, we can decide that's the best thing to do. We wouldn't do that down here because that's not necessarily the best thing to do down here because they don't know who's calling them or why. But our main method is the absolute authority of what our program does, and it knows who it's calling and why it's calling it. So now if we run this program, we're just going to run it really quick, and we should get the number 5 out because by the time, actually we're going to get the exception, look at that. Because the input value is 4, the output value would be 5. So look at this. And you've seen this before, right? So here's what happened. And our catch got caught right here. We caught that exception. We printed out our message. You can see that there was a problem in the code. Number is even, and then we call print stack trace, and print stack trace will print the type of exception, its message, and then the stack trace all the way down to where it happened. So right here, method 5 threw the exception, and then method 5 was called by method 4, by 3, by 2, by 1, by main. And we can actually, IntelliJ will actually take us to the spot because it's the message that picks up hyperlinks basically. So now I've been able to, method 5 can say, you gave me an input value that I can't handle for whatever reason. And it threw the exception, and all of our intervening exceptions, or methods, sorry, decided, I don't know what to do with an exception if I get one, so I'm just going to pass it along. And we forced main to deal with it. Now, let's take a look and see what happens if I instead throw a new runtime exception. This makes it so that I don't have to have a try catch. So if I have a runtime exception, now I'm going to get a couple of warnings here, but I don't actually have to have the throws on any of these. So let's get rid of the throws temporarily. Because a runtime exception inherits from, and this is the example I told you that it's not exactly true that everything inherited from exception is a checked exception. There's one exception that extends the base exception class that is runtime exception, and that means it's not checked. That's what makes it different. That means you don't have to have the throws on it. So then I'm just going to comment out my try and my catch. So we're just going to execute our code. Now method 5 is actually going to throw that exception. But because it's a runtime exception, I don't have to declare that I throw it, and nobody has to catch it. But if I don't, here's what happens. Our program runs, and kablam. It actually happens exactly kind of the way we did it before, except we don't have our line of output here. So what happens is in main, if you do not catch any exceptions out of your main, then they're going to just propagate right up out of your main as well. And then the default exception handler is built into the Java virtual machine that called your main method. And its job is to simply stop your program and dump out the stack trace of the exception. It's very ugly. It scares our users. It scares us as programmers, but it gets our attention, right? And so you've seen this before in your programs. If you've had any kind of a problem with your program and the code that you were calling caused an exception to happen, since we haven't learned about how to handle those until this week, they've just always bubbled up to your main and through your main and out into the default handler in the Java virtual machine, and this is what you've seen on your screen. So even though we don't have to try or catch a runtime exception, it's still a good idea to do that. And it's a very good idea if you've got a program with a main method in it to have your main method just do everything inside of a try block or a try with catch. And the reason for that is that way you don't have anything bubbling up out of your main and crashing your program without you knowing about it. So now if we run this, we're going to see that our exception handler executes just fine. So we got that extra line of output right here. And then we dumped our stack trace. So that's pretty cool. What happens now if there's some section of code that, regardless of whether I get an exception or not, I need to make sure that it executes? Well, that's what the finally clause does. So every try catch block can also have a finally block on it. And we would say system.out.println, I'm a finally block and I always execute after the try. So let's take a look and see what that looks like. And let's actually start our input with 1 so that it's not an even number by the time we get down to 5. So we're going to run this and we're going to take a look at the output. So we get the output value is 6. That's what we expected. And then we see I'm a finally block and I always execute after the try. So no matter what, our finally is going to execute. Java guarantees that, except in one situation. If you call system.exit, there's no guarantees that any code will run at the end of that. And so if you call system.exit, then your finally may not run. And if that's important to you, then you need to handle that in your code. But probably by not ever calling system.exit from production level code. So let's go back and take a look at how this functions just to prove that we're right about how the finally block always gets called, and it always gets called after the try. If there's any catches that have to activate, they'll execute, and then the finally will execute. So let's do that. So there was a problem in the code. That's our exception handler. And we got our stack trace, and then we got our finally block. So that's the finally block. So using exceptions, we can then signal from deep down the method call chain that something happened that caused us to be able to not do what we were asked to do as a method. And whoever called us will either have to decide to handle that, or they could decide to just pass it along using a throws clause on their method signature. So let's see what we're going to do next about this. Let us define a new exception type, because you can create a custom exception. And so I'm going to actually put our throws back on here. And so we'll just use our editing cheats here. Is that everything? That is. Throws exception. All right, now everybody's happy. The code works, but let's go and create a new class. And we're going to create a new class, and we're going to say our, let's see, let's make this a little bit more realistic. We're going to say even number exception. All right, so now we have this even number exception. Add a little bit of formality, indicates an even number was encountered. So you can create custom exceptions for any condition you want to model. And the best thing about it is the type of the exception tells us exactly what's wrong, or what it conveys, all the information it needs to convey. So then we're going to extend exception, extends. So that's what turns it into an exception. If we wanted to turn it into a runtime exception that doesn't have to be checked, then we would just extend runtime exception. And that makes it an unchecked exception. We're going to do a checked exception. And there's a couple of things that we probably want to do. It's a good idea to have at least two constructors on your exception. So there's a public even number exception, the default constructor, and its job is going to be to call super and do whatever the exception constructor does. And then we'll have a constructor that takes a public even number exception and a string message, and we'll just call it, we're just going to pass it along to our super, our parent class. So there's one other exception that's extremely helpful. We're not going to fully demonstrate how to use it here. We're going to say even number exception string message throwable root cause. Throwable, the exception class, this exception actually inherits from a class called throwable. And there's another thing that inherits from throwable called error, and that's something that you can't catch, you can't stop. But the throwable, you can actually catch an error too. So we're not going to demonstrate that. But the throwable is the parent class of exception. And so now we're going to do super message, and I believe there's a constructor for the root cause and the message. Is there? It looks like there is no errors there. So what this does is this, sometimes what we want to do is catch an underlying error condition, but translate it into something that means more to our application. So a lot of times when we're doing a network application where we make a call across the network to go get a piece of data, and for some reason that data, that network call fails, the server went down, or the network is down, or whatever. So we get an IO exception that says, I couldn't do this for you. But I don't want to necessarily make my program handle any old IO exception. I want to say specific what happened. So I would define a custom exception that tells me something about my program that couldn't be done, and I'll wrap it, I'll add it as the root cause, the IO exception that caused the original problem. And that actually helps us, because when we debug, and I think we will show this because we'll show the stack trace in a second, the debug for that will actually print both exceptions. So we'll see what the root cause, why we got the exception if it was caused by another exception. So we've now defined our own exception. We're going to come back to our exception demo here. And we are going to, instead of throwing exception, we're going to say we're going to throw a new even number exception. And rather than throwing or saying number is even, because the name of the exception actually tells us what's wrong, why don't we just give the number? That would actually be helpful. So the number is even, and we'll just say string.value of, that converts the input value to a string easily. And now we'll actually get that back in our exception, and it'll show up down here in our trace. So you'll notice though that I still say I throw an exception here and not an even number exception. That's a little bit sloppy, so we're going to fix that, because this method can only throw an even number exception just because that's how we coded it. So let's fix that. Oh, got it wrong. Even. All right, and then we will catch even number exception here. Now there's a couple of things you could do, and one of those is we could say I will catch either an even number exception or just a generic exception. And I'm going to get an error here for a second because even number inherits from exception, so it doesn't really help. But you can do this in Java. You can say, I don't care what exception I get. It could be either one of these two. And if I get either one, then give it to me in my variable exception. And you can do that with as many exceptions as you want. The alternative is to have another catch block like this. You could say catch exception, exception. And what this does is says, first check to see if the exception is an even number exception. If it is, then do something specific for that. Otherwise, if it's a generic exception that's not an even number exception, then handle it this way. Our method doesn't do that, so we're not going to do it that way. And we're just going to handle our even number exception. So let's actually debug this and watch what happens. When we throw our even number exception here, we're actually going to hop right back to our catch because nothing intervening is going to catch that. So let's do this. We're going to debug. We're going to step in, step in, step in, step in, step in, and now we're going to cause the exception to be thrown because input value is an even number. And we're going to step in, and here we go. We're going to throw a new even number exception. And that's going to, I'll step into this and just show you. We're going into our constructor here. And we're in this constructor that takes the message. So we created our own exception, and now we're going to throw it, and bam, our stack evaporated into thin air, and we're all the way back at the first catch in the call chain, in the method call chain that was able to catch an even number exception. All right, and so now we're just going to print it out. Look at our console here. We print our stuff out, and you'll see we got our number 4 there. And that's actually a helpful exception message. And then our finally executes, which makes us happy. All right, so let's illustrate really quick how to actually wrap an exception. Let's say that up here in method number 3, we're going to have an exception. And we're going to do a try here, and we're going to catch our even number exception. And we can name that variable anything. So this is the type of what we're catching. We're actually declaring an exception variable. This is the data type of it, and this is the variable name. So it can be EX or exception or E, or it can be more descriptive than that if you want. And in this case, we're just going to wrap this exception. We're going to wrap our even number exception in a generic exception. So we're going to say throw new exception, and then we're going to just give it our even number exception variable, its root cause. And there's a constructor on the exception class that just takes a root cause and doesn't take a string, a message. So we're going to do that. So now we have to change these to exception because method 3 doesn't throw even number exception, it only throws exception. And then we'll come back here, and I could get an even number exception potentially, but I got an error here because method 2 or method 1 only throws exceptions. So let us, we could do this. We could just say another catch. And then if I just said exception.print stack trace, that should work just fine. So in this case, this catch is extra. This exception can't come out of method 1 because method 1 doesn't declare that it throws it. So this code is actually extra, but I'm going to leave it in here for a second. So we should actually come in here and print this stack trace. So let's put a breakpoint right here, and let's run our program. And we will do a couple of things here. I think we're going, what I predict is going to happen is we're going to get to method 5. We're going to throw our even number exception, and that's going to hop back through method 4 and into method 3. And we're going to get stopped right here and see that we're going to wrap our even number exception in a generic exception and throw it, and then we're going to hop right back here to this line 13. So let's make sure and see that it works that way. So we're going to hop down all the way to the bottom. We're going to throw our exception right here, and pow, our method 3 caught it, because that's how we wrote it to do it. And now it's going to wrap our even number exception in a new exception, a generic, and we throw that, and now the next method defined in our chain that can handle a generic exception is all the way up here in main. And then we're going to execute this, and let's go watch our console, and pow, and look at that. So now I have a generic exception that was caused by an even number exception, and there's my message for the even number exception, which is 4, and then it tacks on the caused by. So it was caused by the even number exception. So this exception that method 3 threw was caused because method 5 threw an even number exception. So I think this is our demonstration of exceptions. We've demonstrated how to throw exceptions, how to catch exceptions, how to have a finally block. There's one other thing that I'll call your attention to. We've demonstrated all semester long, so I'm not going to have a demonstration here, but the try with resources is a way to have an exception handler, a try, where you can declare a closable resource like a scanner or any other file. And when the try block is done, whether there's an exception or not, there's a built-in finally that you don't have to write yourself, and it will close whatever it is you declared within the parentheses of the try finally. So in our case that we've used all semester, our scanner, that try finally will close our scanner at the end. And if you use VS Code, you actually get a warning if you don't close your scanner. IntelliJ doesn't give us that warning, but that might explain a couple of things if you've been using VS Code all semester. So this is the end of part 1 of the video demo. I'm going to take a break, and we'll talk about files next.